Welcome to today's broadcast. On this fine Friday night, we will be going over some football highlights that took place in the past few games this week. Football is one of the many sports that have a lot to do with physics. Newton's first, second, and third law can be viewed when there is a football game. You might not notice it when you're watching a game, but take a look at these clips right here. In this clip, you can see Newton's first law of motion. If an object is at rest, it will stay at rest, or if in motion, it tends to stay in motion, unless an unbalanced external force acts on it. In this video clip, you can see the player is in motion, and he stays in motion until there is an unbalanced external force, which in this case is the other player. Inertia, which is the player's natural resistance to the unbalanced force, can also be seen in football. In this clip, the football is not in motion and remains resting on the grass until a force acts on it. The player's mass is important in the kick because the higher the mass, the higher the inertia. Let's also make sure that we don't mix up mass and weight with each other. Mass is a measure of how much matter an object has. Weight is a measure of how strongly an object's mass is attracted by gravity. Newton's second law of motion states that force on an object is equal to the mass of the object multiplied by its acceleration. In football, it tells us the amount that the ball accelerates depending on the force applied by the quarterback and the mass of the ball. In the clip, you can see the second law of motion when the player catches a ball that is thrown by the quarterback. The force in this case would be the mass of the football, which is 0.43 kilograms, multiplied by the acceleration of the throw, which can range for different players, but we can say that it is around 23 meters per second squared. So in this case, the force of the football would be 9.9 newtons of force.
Newton's third law says that for every action, there's an equal and opposite reaction. When a football player tackles another player, the body being pushed is going to push back with an equal and opposite force. In football, the energy and motion of two runners after they collide, the motion goes into compression and the energy of collision is transferred to energy in the air that you can hear. Projectile motion is an object upon which the only force is gravity, and it influences the vertical motion of the projectile, which then causes a vertical acceleration. In football, punts are some examples of when projectile motion is displayed. When the kicker kicks the ball, it gives it maximum kinetic energy and potential energy is minimum. As the ball ascends, the kinetic energy decreases and potential energy increases. At the highest point, the kinetic energy is minimum and potential energy is maximum. When the ball ascends, the kinetic energy increases and potential energy decreases. And when the receiver catches the ball, the kinetic energy equals maximum and the energy is minimum.
In football, there is a lot of running and dodging involved when it comes to getting the football to the end zone. When it comes to running, friction and the type of shoe one has is important because it can affect the friction, which is critical. Cleats and the condition of the field play an important part because the rougher the surface, which is the field, the greater the friction the player has in their shoe. In this clip, you can see that the football player is running towards the right, which is the applied force that is done by the cleats by pushing down and back. Since they are pushing down and back, the applied force is going towards the left, meaning that the force of friction is acting in the opposite direction towards the right with high friction because the surface he is running on is dry grass.
Potential and kinetic energy. When a quarterback throws the ball to the receiver, he is transferring energy to the football. As the ball sails through the air, it has kinetic energy because it is moving. The ball also has potential energy because of its position above the ground. An object's combined kinetic and potential energy is called mechanical energy. The kinetic energy of an object depends on both its mass and its speed. So when the quarterback throws the football, the mass of the ball affects the velocity in which it is being thrown. Conservation of energy in football is the amount of energy the player gives to the ball by throwing it or kicking it. It is equal to the energy the ball gains. This means that energy can neither be destroyed nor created. It can only be transformed or transferred from one form to another.
Thank you for tuning in to tonight's broadcast on this week's football highlights. We hope you were able to learn something new tonight with the physics incorporation we had. Stay tuned for next week's podcast where we talk about soccer. Thank you and have a good night.